Ich nehme an, es ist hell hinter mir. Dann werde ich mich nicht umdrehen. Welcome to the ChaosWest stage, everybody. The next talk is going to be held by Bernd about net2o. But please, give me 30 seconds. This is a self-organized session kind of thing with amazing infrastructure. Day 3, that's the day today, is the most difficult day for anybody involved because, you know, we've been in there, we've been partying and everybody is a little hangover. So if you feel like you could help us for half an hour or two, talk to me. There's camera stuff to be done, basically, and that's it. Good. But now, back to Bernd. He's part of the You Broke the Internet and We Fix It.
Yes.
So Bernd, fix it, the internet, and this is amazing. So an applause, and then the stage is for you.
Thank you. Okay, I'm holding a talk about 3 topics. If you have been on the IPT and We Fix the Net sessions the last few years, I already held talks about the lower levels. And nowadays, net2o's lower level work quite well, so I'm concentrating on the top level, the part where you can use it. And this presentation is rendered in the user interface thing I want people to use as browser replacement, because our browsers are too big and have too many attack vectors, so we need to find a new way to render things. But first, let me give an overview over the motivation. So, somebody broke the internet. It's not just the NSA. I think we all broke it by adding too many complex things and too many protocols and too big browsers, and everything is old and over 30 years. So when something is over 30 years old, you can't trust it anymore. So 4 years ago, Snowden pointed out how big the internet is broken, and the politics responded to that by adding new threats to the internet. So we now have a censorship which approaches the way China wants to censor the internet. Well, they do it, but it quite not works as well as they want. So now our politicians also want to censor the internet, and they have fake news and hate speech. So fake news means everything except Fox News, as we know, and hate speech is probably everything except applause for Donald Trump. We have crypto wars rebranded. Instead of increasing the numbers, it's now reasonable encryption. We have a number of dragnet surveillance laws which legalize what they have been done before. We have the kill the link decision from the LGA Hamburg. We have people like Jim Sensenbrenner saying, you are not forced to use the internet. And well, I don't know if it's good or bad, because 2017 was quite exciting for crypto. Crypto now means bitcoins. It no longer means encryption of your private messages. Forget about that. Crypto now means bitcoins, and you can make a lot of money with it. This is from last year with the competition. The Tor project faced some kind of Stasi-like Zersetzung. And well, maybe due to their link to WikiLeaks, which faced the same sort of Zersetzung 6 years ago. And we want to have some solutions. Net2o starts to become usable. GNU-net starts to become usable with CQ share. It's going to look a bit better than it looked before. So, for those who haven't been here last years, an overview over the layers of net2o. So the layer 1 is physical layer. Physical layer is not part of a real protocol is just the wire you have. And for the existing internet, you use UDP as layer 1. So you use the existing internet with UDP, with very lightweight, as layer 1 of all those protocols which stack on top of it. And when we finally replace the internet, we can remove UDP and do it directly on the wire. Next layer is then label switching, path switching. So you can join a number of short labels and switch packets through a path. The source has to route the packets, not on the fly. So that is quite good for high bandwidth, for scaling. And when you have big tables on the routing tables on the internet, and when you have insecure means to announce routing tables like border BGP, then you want something more secure, faster, and you want something different. The way the internet did with routing and every hop was quite good for the time being, but you can do better. Next layer is we need to encrypt everything. There's no encryption. You need to have modern encryption standards, not the old one. You don't want to carry a big library of encryption you never use because it's already broken. Next layer is the, let's say, TCP layer on the internet. So you need some flow control, some congestion control, some retransmits if packets get dropped, and that is here is timing driven instead of window driven. So even when you have packet losses, it's not going to slow down. And then I need a layer where I pack structured data and where I can send commands. I do that with a stack-oriented tokenized command language based on force, but not Turing complete. If you know Bitcoin smart contracts, they use about the same thing. Developed at about the same time, completely independent from me. So and if you look at the Java virtual machine, you have a Turing complete machine that is also using stack-based language. Then you have the layer with files and messages as distributed data and distributed hash table. And on top of that, you can put your application. So last year, I gave a talk about onion routing as to provide anonymity. But onion routing has a big problem, that is timing correlation. If you can sample enough package, you can de-anonymize everybody who is using Tor. So that is for low profile targets is not feasible. If you're just using Tor to browse your internet and go on Facebook without being attached to an IP address, you are still revealing a lot of your data to Facebook, but the de-anonymization is not really feasible. So that kind of silly Tor usage is okay. But if you are a target, Tor does not help you. If you're like Silk Road, or if you are a journalist which does things Donald Trump or the Chinese or Putin doesn't like, Tor does not help you. They can track you down. So one topology that is better is a mixnet, but a mixnet has a big disadvantage. Mixnets collect messages until their buffer is full enough, and then they spread out the messages in random order. So no correlation is possible or not very easy. But that takes time, and people want real-time experience. So what to do? The easiest solution is just to push out garbage with a constant bandwidth. And if you get something in, you push out the contents instead of the garbage. That's what I'm going to do. Instead of having just onion routing and timing attacks, add enough garbage that there's no timing correlation possible. And to get more bandwidth, I plan to have a multi-pass solution. So you're not going to use just one switch circuit, but a number of switch circuits, which are each give a guarantee of a low bandwidth. But together as aggregate, you have enough bandwidth to have fun, to have real-time fun. That is plan on the not on the lower levels. All the other lower level part is finished. I'm just not finished with the anonymity part. So now we go to the browser, the user interface part. The code name is -2 because 20 years ago I wrote a user interface in the time where Delphi was very popular, and I decided when they have Greek, I use Greek, so mine is minus. And I completely rewrote that 20 years later using OpenGL as basis, because you have OpenGL almost on any smarter device like smartphones, laptops. Even on Windows there's still an OpenGL driver available. It's possible to use also Vulkan, but I think it's overkill because it's not a game engine. This is just render your text. I use FreeTypeGL for the fonts. FreeTypeGL is a very small project, and they are not working very hard on it, so I forked it off and added the things I needed. I use Soil2 for images. It's also a very small project, and the small projects have the big advantage that the attack surface is not so big. I want videos to textures, and unfortunately that is a lot more work, so I need to use the big frameworks like OpenMax on Android and GStreamer on Linux. When you are familiar with the coordinate system on Windows or on X, you usually have this coordinate system with the origin on the top left, and in OpenGL it's like Mars, it's on the bottom left. So you have to rethink a bit. Typesetting is done like LaTeX. You see, I can even do the logo of LaTeX, this kerning, this rising, lowering. So you are not going to have a poor typesetting. Fortunately, LaTeX is not really tech is not really complicated. It's just powerful. But it's a relatively simple program in today's standard. It's printed in one book, so it's a few hundred pages of programming code. Normal things we nowadays see, you couldn't print them out like a Mozilla browser. You would run out of paper before you print out all the source code. I want to have very few classes. I want to have a very lightweight, object-oriented system. I want to use combinatoric stuff, not many different, slightly different things. So that are the base classes. Editor, text, emojis, icons, image. You can have animations. So that is essentially everything that is visible. And you have boxes, horizontal, vertical, and stacked on top of each other. That is what LaTeX doesn't have, is stacked on top of each other, but the other two LaTeX has. So it's based on the way you do LaTeX. And you can either render to a texture or to a display. And so you don't have too many things to consider. And it's very, by combining all these things, you still have a lot of power to do your rendering, to do your markup, and build frameworks to display things. Because it's not like HTML is for everybody. You know why HTML is so bloated, because everybody wants to render something different. Somebody wants to render a map, the other person wants to have a small game, and just pushing it through already structured text is not the right way. So this layering is wrong. You put the structured text on top of the objects you want. So I start with the document object model, not with the structured text itself. For animation and things, you want to minimize draw calls, so I'm drawing different things in layers. Each of them is one draw call. Only the image takes one draw call per images. So I think we can go to the next point. In 2017, the big thing was crypto, and crypto means some money on the internet now. It does not mean send your messages. So I thought about, why do they want this Bitcoin? Why do they want the blockchain? What's wrong with it? What can we do about it? What's needed to do? What's not working well with the system? Can we fix it? Is it broken? I think yes, it is broken, because Bitcoin is just a proof of concept, and it way outgrow what it could do. So it's not broken in the sense of that Bitcoin as proof of concept is wrong. It's wrong when you scale it up. That are my topics. It's not just technical, it's also ethical, it's society, and it's about history, because I think one of the shortcomings of Bitcoin is that the concept of money there is a libertarian concept of money. It's not very scientific, it's not modern. And let's go about the history. Fortunately, when we talk about the history of money, where things first, we don't have to leave China, and it's essentially all Song dynasties or 1,000 years ago. You can learn a lot from this history if you look closely, because they made all the mistakes the West did in the industrialization 800 years later. So how did money start? Money started with the shells. The cowrie shell money is about 30,000 years ago are the first cowrie shell objects found, used as jewelry and used to exchange things, because cowrie shells are somewhat rare. They are very difficult to imitate, to fake. Even today you would not be able to fake a cowrie shell. Even with the high level of sophisticated material we have now, you cannot fake a cowrie shell. It's nanotechnology, it's a living thing, it is really difficult to fake. So that is an object with an inherent value, just as jewelry, but it is inherent somehow. And you can exchange it with other objects with inherent values. That is the oldest concept of money we have. And the bad thing about cowrie shell is that it's gaining value the further away you get from the shore, because it's a maritime snail, and you have to collect it on the shore. And when you are in the mountains, a cowrie shell is pretty valuable. So the people in the mountains came up with an idea. They mined metal. they made imitations of cowrie shells with bronze. And so we had the first metal coins. And also in Greek, we had an independent development metal coins. So metal coins is where you mine, where you have the inherent value because the metal is rare and there's a lot of effort to take out of the mountain. The problem with this rareness is if your economy grows fast, you run out of money. You have a lot of valuable things to exchange, but nobody has spare money. And the Chinese came up, the banks came up with promissory notes. So it was not the state, it were banks who issued paper saying, we give you 1,000 coins if you hand in that paper. And the merchants liked to use the paper and the banks liked to use the paper because they could overcommit their coins. You don't need to give everybody coins, only those who actually wanted coins. And next step was that the state discovered, oh, we can do that ourselves. Instead of minting expensive coins, we print cheap paper, put a seal on it, have a controlled procedure, and punish everybody who makes fake paper. And yeah, what they discovered in the process is we don't actually need the coins. The paper is good enough. That was the last one in the Mongol Empire in China. They dropped binding the currency on silver. They just issued paper. They had a mild inflation of about 2 to 5% per year because that improves the economy. People spend more when there's an inflation. When the inflation is not big, is the function of money still is good. So over 200 years, money became, I think, a factor of 100 inflation. But it's not so bad. Year to year is not bad. It's just people who want the coins don't like it, and deflation is much more problem than mild inflation. Big inflation, of course, is also a problem. Money works by the constant, what you want for money is that you have a constant factor to exchange it with other valuables, or mostly constant. Slight changes are okay, but big changes like the Bitcoin spikes up and down, that's not okay. So yeah, what's the problem with Bitcoin? The lower problem is the value is very unstable and it's a bubble, and it looks like a very textbook bubble development. So it's now in the phase just before collapsing, when it follows the textbook. We don't know, you never know if it follows the textbook exactly, but it looks like a textbook bubble. But from a technical point of view, the proof of work is way more dangerous than this bubble development. Because proof of work is dangerous to the environment. You have to, I think we have now 30 terawatt hours per year for just mining Bitcoins. This is an incredible amount of energy we need for a relatively small amount of transactions that are signed with these expensive hashes. And it's not even very secure, because the attack vector Bitcoin looks at is what happens if someone fakes the last block. As that's not the most profitable. The most profitable is fake the entire chain, because then the mining here was very cheap. And the mining here before the Bitcoin exchanges started was even cheaper. So when you fake the entire chain, you have about 16 million coins now. you need to invest more work than was invested in the real chain. But most of the work in this current chain has been invested in the last 3 months. It's not before mining was not so profitable. So faking the entire Bitcoin chain and getting all the Bitcoins as reward is a way better attack than just faking the last block. So it's not very secure. Then we have the problem with the deflation. Deflation works like this. As inflation is money's cancer and deflation is the infarct. Nobody's going to spend Bitcoins to buy something. Everybody is using their Bitcoins to speculate. They do day trading maybe, and then they need transaction. But to buy things, to sell things, Bitcoin is useless. So typical sign that even spam sending is now, you get spam, join the Bitcoin wave or the Ethereum wave, and you don't no longer get Viagra spam. So this scheme is very profitable. Yesterday somebody from the Bitcoin group said they want to do the exchanges on-chain or with decentralization. That is a good development, because if your thing only works for exchanging, for speculation, all you need is the exchange. And when it's decentralized cryptocurrency, the exchange should be on the chain, on the blockchain. That is not in some bank like Mt. Gox, which went bankrupt, and I don't know if these exchanges will go the same way when Bitcoin collapses again. So there are things to do. And this is about ethics. So the Bitcoin people are pretty religious often, and they are like these banksters, so they say, have you a moment to talk about our Lord and Savior, the free market? And I think they have 3 seconds, and then they will go day trading again. So it's maybe not so bad as Mormons or Jehovah's Witnesses. But there's a religion about free market solves everything, and the Bitcoin universe already has a verse. Just after a few years has a worse distribution of wealth than the neoliberal economy managed in the last 30 or 40 years. And inequality means that society is going into serfdom. If you if you aren't a Bitcoin millionaire, you have to work for the Bitcoin millionaires. And that happened in almost any society where money was deflationary and the economy grew fast. The money is attracted by those people who had already had money, and they make more and more. And we had the robber baron economy in the Wild West. And in the Song Dynasty, China, we had about the same problem. In North China, they solved it by a revolution and killing all the gentry, and in South China, they solved it by an organized change of how the state worked to a more socialist model. But something needs to be done to be fair and equal. So this deflationary system is not fair, it's not equal, it makes people rich, and most of the altcoins follow this model, because when you issue an altcoin, you want to become rich quickly. So you make a white paper, you collect Bitcoins, you give out your coins, your now worthless coins, and hope that you find bigger idiots who buy them and sell them to even bigger idiots, and that's how these Ponzi schemes work. It works quite well until it crashes. So now about the actual technology beef. What do you want to prove when you have a blockchain? What is your challenge? The challenge is you don't want double spending. You have digital money is just a number. Numbers can be copied without problem. We want the number to be unique, uncopyable, just in one blockchain. And Bitcoin came up with this proof of work. It sort of works, and it burns a lot of ASIC miner energy. It is very costly, and it's marginally secure. And what it's also doing, it's centralizing the process again. The idea was decentralized, but now we have 5 miner pools all in China, and they do a centralized proof of work. They distribute the actual hash computation to decentralized parts, but the selection, whose transaction goes in, is done by 5 pools. And if they don't want your transaction to go in, it does not go in. So Ethereum suggests proof of stake. And yeah, that works because we have that is called banking system. The banks have a stake, and they we trust the banks because their own money is at risk if they go away with our money. But that also has problems because money corrupts, and since 2008 the banks don't trust each other even though they have this proof of stake. So proof of stake is probably not much better than what we have now with the banking system. It's not a replacement. What I suggest is proof of well-behaving. We must see that the attack for double spending is not just create your own blockchain. It's also you must make this blockchain public. So you need a man in the middle attack. If the people already know where to get the most recent block, and they trust the person who gives the full node who has the most recent block, only this full node can misbehave. And also, when we look at this game theory thing, when you just sign one block, you can decide, do I cheat or do I play honest? Each time you can decide anew. When in the Bitcoin universe, the signature is completely anonymous, it's just a hash, nobody knows who did it. So it's just one decision each time. You can cheat now, you can play fair next, and nobody is knowing you cheated this time. We know from game theory, if you have a repeated prisoner's dilemma, so you are known, when you cheat now, nobody wants to play with you. And this repeated prisoner's dilemma is what makes people trustworthy. Even if they are gangsters, even if they don't want to be honest. If you look at the mafia, they have this omerta, and that works by repeated prisoner's dilemma. You don't cheat on the Godfather, you don't cheat. It's not possible. You will be dead. And the punishment is much bigger because you want to repeat your actions. You don't want to make it one time, cheat, and then be an honest member again. So sign the blocks, know the signers, use a PKI system, have crypto parties, know the persons who do the signing. You don't need to know the persons who spend the money. That can be anonymous. But the trust is much better if it's not anonymous. So last question is, how do we scale the blockchain? The Bitcoin blockchain, you know, it has about a few transactions per second. When we look at the competition, micropayments on the internet like WeChat Pay, they peaked off last Chinese New Year with 500,000 transactions per second. And that is for 1/10 of the human population. So if everybody wants to use this online micropayment system and send friends small gifts, a few cents each, and you will want to have 5 million transactions per second. And it's not going to work when it's on one computer, when it's one blockchain. No matter how much bandwidth you have, how much signing power you have, a centralized solution is not going to work well. So we want it decentralized, we want it not just replicated ledgers, we want partitioned ledgers, and we still want to be able to check every transaction. Not like the Lightning Network, where we do all the transactions in the Bitcoin network off-chain, and maybe we have to arbit all the corrupt transactions that didn't arrive, and then the blockchain would be needed and would quickly overrun. The limit of transactions on-chain is not enough to arbit a lot of broken off-chain transactions. So what I suggest is to use the standard practice of bookkeeping. You have double entry bookkeeping, and that allows you to cross-check all your bookings, even if you have many books. So if you have a distributed, partitioned ledger, all of your transactions going from one ledger to the other must sum up to 0. No matter what you do, the accountant has no money in the system. So all the entries come from outside. Everything you add has a balance, has a negative. You have a debit and a credit entry in the system. When you put money into the system, you say, we promise you, we give it back to you. That is the credit. And this money now is in the system is the debit. Then you can quickly check that all the bookings are okay. And you can partition the ledger by coin pub key. And you can use an n-dimensional ledger space to have only small parts of the ledger space talk to each other in each cycle, and then you switch to the other dimension for the next cycle. That's what I'm doing. I'm now developing the concept. That's what I want to add as application part. Before I thought using GNU Thaler is good because it moves all the hard part over to the banks. But one problem is the banks don't trust each other. So in capitalist America, bank robs you. You have the problem with Lehman Brothers, with the complete trust of the interbanking transactions eroded in 2008. So that's why the bank want blockchains. They don't trust each other. And the last thing I want to talk about is how to mine coins. So normally, a blockchain is just for assets. You can do normal real-world assets in a blockchain. You can do euros, dollars, you can do real estate in a blockchain. You just must make sure it's not possible to hard fork this blockchain, because if you hard fork a real estate blockchain, the real estate would be in this Bitcoin and Bitcoin Gold and Bitcoin Cash 3 times. Which one is the right Bitcoin? We don't know. So you must, when you do real things in the blockchain, it must avoid hard forks. But how do you mine the coins? The typical altcoin is mined by creating a lot of coins, and before you start with the project or while you do the mining. And I don't want to have expensive mining. for signing the blockchain. I don't want to use expensive rewards there. So you need a different process of mining. What's the idea of mining? The idea of mining is you have to do something difficult. You have to do work, but it should not be automated work because that just burns energy. It should not pollute the environment. So if you mine gold, it's not ethical mining. Mining gold is one of the dirtiest things you can do in the real world. And mining bitcoins is about the most unethical thing you can do in the virtual world because you really burn fuel for value, which is compared to the rest of the economy is about nothing. And my idea is a number of free software projects and other scientific projects live from donations. Now we give the donation to the project, we don't get anything directly back, we get the software back, we get the knowledge back, but we could just issue a voucher, a tradable voucher, return back that voucher, and you could trade your donation if you decide, I want to donate now, because I think this project will become great next year and many people will donate next year. I donate now and sell my donation next year to all the other people who also want to trade with these vouchers and donate to this project. And that is, of course, self-interest of those people who want donations. It's also in the self-interest of the people who give donations, and it is in the interest of society because we get founding of free software, we get founding of other interesting projects where we now have difficulties founding because people, when they now donate, their money is lost forever. They cannot reclaim it by selling the voucher to somebody else. They must make a tough decision. This would make the decision maybe easier for people to donate and add an incentive to be speculative about donating to projects which are early and not donating only to the big projects which already work well and are well known. That is, when the project is well known, the price of its donation is higher than when it's new, and I think that way we can use the hype about Bitcoin and other coins to do something useful instead of just wasting more and more energy. And that's it. I have 2 links now, and you find a lot of more links on when you surf those. So, yes, I'm ready for questions.
Thank you very much, dear Bernd. Questions from the audience now?
I have a question about Minos. If I got you right, you made this presentation with Minos, is that correct? And how did you do it? What would I have to do if I wanted to make a website?
Yeah, at the moment it is just the document object model, so you have to fill in the document object model with entries. And I can show you the source code. But later you shouldn't do that in source code, you should use something like Markdown, but I don't have a Markdown parser right now. So the source code of the pages itself, first I define some macros, like here this LaTeX. Now that is a macro definition. I want to render the LaTeX logo. I need some string. I create a text object, a small text object, and I need to do race and kerning. But that is just filling. That is all written in Force, and we will have a talk about what is Force in the evening at 18:30. Now all the net2o is written in Force, and fortunately this helps me to write these macros quickly. I don't need to write a new programming language. And let's see, that is how you then create a page. So if wrap up, you have a frame on the bottom with a color. You select the color of the font, you set some baseline skip, you set the font size is large, you create a text, you arrange it center, you change the color of the font, and of course when you have a markdown parser, the markdown parser would just go over the markdown and fill in the document object model with the text it found in markdown. But here everything is done manually, everything is done with commands right on in the source code. Fill the document object model. So this is manual work I'm doing now because I don't have the higher levels, the markdown parsers. I will add that later when everything in the document object model is ready, I can add a parser on top of it. I think markdown would be my favorite for this kind of application because everybody knows markdown. People seem to like it, unlike HTML. They don't like HTML, but they like markdown. So that would be when I have the markdown parser ready and you want to make a presentation, write it in markdown.
Yeah, what is the overrun the arbiter attack? You said Lightning Network is susceptible to overrun the arbiter attack.
Yes.
I'm not familiar with that.
Yes, look, you have 5 transactions per second in the blockchain. The Lightning network works by not checking the actual transactions. And if you think your transactions didn't come through, you push the Lightning transactions to the blockchain. So let's say you have a queue of 5 hops from A to B on the Lightning network, and it didn't arrive at point B. So you push all the nodes in between to the blockchain. You need 5 transactions in the blockchain. But let's think we do 1 million transactions per second in the Lightning network. That is entirely possible, no problem. And 10,000 of these 1 million transactions don't arrive because some evil persons took the money and ran. So now we have to push 10,000 Lightning transactions into the blockchain to do the arbitring. And the blockchain can only do 5. So the risk of getting caught when you run away with the money in the Lightning network is very small. And this overruns the arbiter actually is a real world phenomenon. If you order something in China and you don't get what you want, you could go to court in China. They actually have a court system, but it's completely overrun. So the likelihood that this case goes to court is about 0, and that is why the Chinese merchant cheat you. It's not because there's no law, it's because the arbiter is overrun.
Thank you. Well, you talked a lot about ethics, but I think cryptocurrency is about science and facts, so ethics shouldn't really matter. You had a lot of problems with proof of work. but I very much doubt that any system without proof of work will work in the long term, like won't be centralized or will suffer from Sybil attacks. I just want to get your comments on that.
Yeah. Of course, you have problems with every system, but the proof of work we have now is already centralized in Bitcoin. We have these 5 pools. The actual work is decentralized, but the choice which transaction goes into one of those pools is made by a central instance. And work has economy of scale. And if you say who is going to do the work with the proof of work system, it is going to be those people who can do it the cheapest. So that is why we have miners in Iceland, in China, in Mongolia, because they can do the work, which is actual machine work, it's not human work, cheapest. And that is centralizing by itself. So when you have proof of trust, you don't give a big incentive to the people who sign the chain. It's not, because signing is not expensive. The operation is not expensive. But what is expensive, what must be expensive for them is to gain and retain the trust. So that means auditing. That means you have to be known in person. That means we check where you live, if we can get you into jail if you cheat. If you say, I'm from Nigeria, I want to join, and we figure out there's no way to get you in jail in Nigeria, but when you cheat us, we will not accept your signature, or we will rank it down, at least. So we can use existing systems of keeping people honest, and we can also build our own. We can make sure we meet the people at crypto parties. We know they are honest. We know what person that is, and we know it's not this 1,000 people is just a sibling attack and there's really only one guy behind them, because we want to show this guy. We want to see this 1,000 people. We want to see them, and that makes sibling attacks difficult. As PKI is not an easy problem, it's not a problem that can be solved with technology alone. We know that from our crypto parties with PGP, and we know that people don't quite like to come to these crypto parties, but when you do something which is has a high responsibility, we can also ask you to do the effort to prove you are honest and real. And about science and ethics, we are talking about economy. Economy is game theory. So that is math. But the result of game theory is ethics, if you do it right. So ethics is a scientific topic. And you can use math to do it.
Any more questions from the audience? Thank you.
I have one more question. Isn't it that there is actually some value behind Bitcoin because it's used on the black market so it has basically some unethical value, one could say, mostly. And I mean, there are these speculative transactions, but you also have this in other markets, like I don't know, in Dow Jones,
like Silk Road or things.
Exactly, and I mean, in real world markets, you also have trading bots which also do highly only speculative transactions, and they make up a large quantity of the volume.
Yes, of course, market means that you have speculation, and anonymity of a currency means you also have people who want tax evasion and illegal business. That is clear. But that is something the real world currencies also facilitate. You can use cash And
when do you
it's just maybe more expensive, but when the transaction fees of Bitcoin rise higher than the transaction fees of sending a suitcase full of money to somebody else, maybe the drug dealer will go back to cash and not use Bitcoin. We don't know. It's just they take the cheapest that's available. And I'm not for full anonymity, for completely hiding like Monero or Zcash, where you have an expensive operation, so you can even hide the amount of money transferred and hide the networks. Where does the money go to? I think that is overkill for honest transactions. You just want to vanish in the mass. You don't, like what I said before with the Tor network, there's the honest user, which is not a target, is safe. So I want to have a system where the honest user is safe because there are so many of them and the target is not safe. So if you do Silk Road, your onion routing can be broken and your Bitcoin can be broken. And they did it with Silk Road as well. So even Bitcoin is not secure enough for this kind of Silk Road things, which is why I heard that most of the drug dealers now use Monero and no longer Bitcoin. I don't want to be part of the race for the most unethical business that others can do that, and they will suck away the bad guys from the simpler and less cost-efficient systems. When you do bad things, you want to pay the cost for doing your bad things. The good people don't want to pay the cost. So make it simple, make it secure enough for normal transactions, where you would have to sift through a big heap of data with a lot of computation power to find everybody. That is okay for me. I don't want to be perfect with anonymity in money exchange. It's not ethical, because just look at what kind of bad things people can do.
Okay, audience, there's one more question.
This in total sounds a lot like not censorship resistant, very controllable. You control who has trust, so it's easy to censor. You don't want it to be used like real money. Like you cannot do bad things with it. So you need an arbiter who decides what is a bad thing to do, and it shouldn't be used for that.
The arbiter doesn't know what you do with it. The arbiter only knows you make a transaction. And due to the trust system, if you as arbiter decide you are not going to let this in, and the next arbiter decides I'm going to let this in, you may lose your trust. That is the danger. So if you try to censor as arbiter, there's not just one arbiter, there are several arbiters. If you try to censor, you might lose trust because the other arbiters all takes this transaction. You become a minority, and if you misbehave, you lose your trust, you get thrown out of the arbiter system. So you wouldn't do that. And you don't know what it is, what the people do. You know how much money it is, but you don't know, is this buying a car or is this buying drugs? You don't know.
But you just said that you don't want to support people buying drugs on the black market, and you're fine if the anonymity is not that big.
I'm fine if you can figure out who gets all this money, and when the police already knows he's selling drugs, they just want to have a proof that he's doing it. Then they can figure out who is this guy. Like Silk Road, the police knew there is Silk Road, it exists. We just have to find the guy who operates him.
Bernd, thank you very much. Thank you. Applause for Bernd.